This is an introduction to Amazon HealthLake. I'm Jeet Sikand, a certified solutions architect in the healthcare domain. HealthLake is a HIPAA-eligible service that uses medical natural language processing as well as ontology mapping to provide healthcare and life science companies a complete view of population health data. It does so in FHIR format and allows for query and analytics at petabyte scale. Let's look at some common use cases for healthcare and life science companies. Users can manage population health more effectively using the advanced analytics tools and machine learning models. They could look at health trends, predict outcomes, and even manage costs. As HealthLake provides a complete timeline view of the patient's medical history, users could identify opportunities to close gaps in care and apply preventative treatments. Hospitals could really optimize their efficiency by applying advanced analytics and machine learning to the structured data inside HealthLake, and therefore optimizing appointment scheduling, reducing unnecessary procedures, as well as predicting hospital bed availability. Although it's relatively new on the market, this service is seeing a rapid pace of adoption. It's used today by the Rush University Medical Center, by Cordica, a provider of healthcare services to children with autism and other brain conditions. It's used by the Cerner Corporation, a global healthcare technology company, and many more healthcare and life science companies. Next, let's take a closer look at where HealthLake can be used within the organization. In the highly competitive healthcare arena, now more than ever, business teams are laser focused to accelerate patient insights and do so on a tight budget. Companies want to be the leader when it comes to compliance initiatives and also want to be able to reduce the gaps in care. On the other hand, IT teams are also under pressure to lower the cost of data integration and also ensure that the systems are scalable and meet the aggressive SLAs. One of the biggest challenges these companies face in meeting these objectives is that the patient data is often trapped in EHR platforms and on on-prem siloed applications. This data is often incomplete and inconsistent. To make it worse, it's also unstructured, with information contained in clinical notes, lab results, insurance claims, recorded conversations, ECGs, and many more non-traditional formats. This is exactly where HealthLake comes into the picture. The patient data from these systems can be converted from older formats such as HL7v2 and CCDA into FHIR format and then moved into HealthLake data store using import APIs. As data is moved into the HealthLake data store, the integrated medical natural language processing algorithm detects and extracts entities, for example, the medical procedures and the medications. It also looks at entity relationships, for example, a medication and its dosage. Along with that, the entity traits are looked at as well, for example, if it's a positive or a negative test or the time of the procedure. And by doing so, HealthLake creates a complete chronological view of the patient health data, including prescriptions, procedures, and diagnoses. It is important to note that HealthLake secures all the data using encryption keys. It leverages CloudWatch and CloudTrail for detailed monitoring, and the well-documented APIs simplify the integration. In order to meet the advanced query and analytics use cases, the normalized data from HealthLake would first need to be exported out. It could be exported to Amazon S3. From there, the Amazon Glue Crawler, a program that determines the schema of data, would read the exported data and create metadata tables in the AWS Glue Data Catalog. Having the necessary metadata tables in the Glue Data Catalog now sets the stage for Amazon Athena, an interactive query service that allows standard queries to be run on the data. With Athena now having access to the normalized data from HealthLake, QuickSight, a business intelligence service from Amazon, could be leveraged to create visualizations and dashboards. For example, users could build a population health dashboard to drive better and faster decisions. Additionally, Amazon SageMaker could be used to further build, train, and deploy machine learning models on the data, and therefore gain from the benefits of predictive analytics. In addition to the analytics use cases we've just seen, HealthLake's powerful search and read APIs out of the box could be used to query specific records based on parameters and resource IDs. This would be ideal to meet the CMS interoperability compliance use cases, where third-party and peer-to-peer applications could request the patient's medical records with the member's consent. I hope you now have an understanding of how this powerful service extracts meaning from unstructured data and supports analytics and interoperability use cases. If you got value out of this presentation, feel free to like or comment.